the DS9 developer is Bill Joy, who is also now part of the Science Data System group at the CXC. DS9's been around. SAOImage has been around since the early 90s. DS9 I think started in around 95, 97, somewhere in that area, and it still continues to be very widely used. Some 40,000 downloads, I think, per month. It's a very popular application. But like I said, I'm not the actual developer, so if you have that kind of tech questions, we'll have to defer them to Bill. But I'm kind of one of the biggest fanboys, so I play around with it quite a bit. So first thing you should know about DS9, if you don't know, is that everything you can do from DS9 through the GUI, through clicking the buttons and clicking the the menus and going through all that kind of stuff, all of that stuff can be done through the command line using a protocol called XPA. If you actually look at the DS9 documentation in the reference manual, you'll see this XPA access points. There's a whole bunch of literally everything you can do through the GUI, through the interface, graphic interface. You can do it through XPA. You can also do it in other ways. You can also control it by SAMP and through HTML and all kinds of other avenues to control DS9. So that's kind of your first advanced kind of topic here. So one of the latest things that came out in DS9, specifically, I think this was 8.2, is the ability to actually change the interface. This is the way DS9 has looked, I think, since like DS9 7. You get the stock gray background, you get the stock fonts. It looks like a 20-year-old application. So one of the new things that's available, and I apologize for the Mac users who are using the native Darwin version. You don't get this, but if you're using the X11 version where you have to have exports installed, you'll be able to do this. And I think in Windows you also have this ability. If you edit preferences, you can now change the theme. So the default is the default. One of the most common things that everybody's asked for is dark mode. So you can now set a dark mode theme for DS9. You'll notice that the background changes to the default dark mode color. For those of you on Ubuntu, the Radiance theme gives you a very Ubuntu looking color scheme and fonts and whatnot. For those on Fedora or Fedora derivatives, Red Hat, CentOS, ClearLooks is kind of your system level kind of thing. I prefer this one called Green, so that's the one I'll be using in my stuff. While we're here, just wanted to note, so some things you can just keep in mind is that, number of threads here says 16. So there are parts of DS9 that are now multi-threaded. And I'll touch on those a little bit later on. And you can also do things like change the background colors if you don't want, if you want the background color to actually be black, and then it doesn't do anything, but then use background color instead of theme color, then you can make the background colors all black kind of thing. So I'm sure everybody will be playing around with this now, going through each of the themes and picking their favorites. So while you're doing that, I'm going to go ahead and close this out. Oops. And let's see here. So I'm going to be cutting and pasting a lot from my little crib sheet. If you downloaded the tar file, there's a file called doit_cds 2021. I'm cutting and pasting commands from there. To get things to work. So this is now DS9 with the Green theme loaded. And I'm going to go ahead and load another data set here. So here we have a nice image, Chandra image, composite image of G310.6 minus 1.6. For those of you who've looked at Chandra data, you can recognize that there are multiple chips. So this is the background, or this is the back illuminated chip, front side illuminated chip. You see multiple observations because this one's tilted this way and this one's tilted this way. It would be kind of nice to be able to identify what observations are actually here. And hopefully this is going to work. So one of the new features in DS9 is the ability to access the Chandra footprint service. And for those of you who want to really get into all the advanced stuff in DS9, all the really good stuff lives in the analysis menu. And my second pro tip for those of you who haven't tried this before, this little dashed line here, if you click it, you get to tear off the menu. It always seems to surprise people that you could do that, and there's always one person who gasps and says, "Oh my God, that would have saved hours of clicking." So that's a very handy kind of thing. I'm going to close this here in a second, but so under analysis, there's footprint servers and Chandra. So DS9 is making a call out to the Chandra footprint service, which is hopefully up and running. It's been having some problems. And it may, oh, okay, good, awesome. So with footprint servers, so you give it an RA and a DEC and a radius, and it tells you what observations are within that cone search. So it now has returned each of the observations, and you can see that this data set is actually a merge of all of these guys. You can pick out the field of view here. Apologize for anybody who's red-green colorblind. I have been to talk to Bill about this, but if you click on the observation ID, you get to see which field of view belongs specifically to which data set. And if you scroll over here, you can see more information. So this gives you the OBS ID, RAs, and DEX. Whoops, scroll up. Things, whether it was ASSI or ASS, exposure number, gradings, all that kind of fun stuff. You can also go the other way. So I can click here and it will show me which field of view it is. If you go to edit, and actually I can do it up here first. So edit footprint, which you'll notice here in this menu is FP, F for footprint. I can now click on the footprints here, so you can now identify which observations belong to which, or which part of the observation you're looking at belongs to which OBS ID kind of thing. We can go ahead and clear this, and we can, so DS9 also can talk to the HST footprint service. Unfortunately, there's no items found, so I'm assuming either HST hasn't actually looked here, or the call is their footprint server is not online. I'm guessing since it says no items found, that it really was there's no observations, but that's unfortunate. So that's great whenever you have footprints that you have something that either is Chandra or HST, but sometimes you have observations where that another mission has observed the same field, and you want to kind of overlay their field of view on the Chandra field of view, or the their footprint or their mask on exposure map, whatever, on top of the Chandra data. So we can do that too. And this isn't necessarily new. So I'm going to load a different data set now, which is SDS blah, blah, blah. And I know I'm going really fast through this stuff. So if something's not clear, raise your hand or actually yell at me, because I probably won't see somebody's hand raised. Or write something in the chat, and Antonella can stop me if I'm going through things too blazingly fast. So here again, I've got a merge of observations. Now, XMM doesn't have a footprint server that DS9 can talk to right now. I don't know if they actually have one or not, but so instead of accessing the footprint, I'm going to access the masks, because XMM does produce exposure maps. The 2D image identifying what part of the field was imaged. And I want to overlay those exposure maps on top of the Chandra data to see what part of the field XMM also observed compared to what Chandra observed. So this was analysis, mask parameters. So file open, and we're going to go into the XMM directory, and I'm going to load the PN exposure map, and it gives me a dialog asking what color do I want the mask to be. So I'm going to make it, sure, we'll leave it red. And we can now see that it now overlaid the PN XMM mask on top of the Chandra data. Again, masks aren't new. Masks have actually been in DS9 for a really, really long time. Again, it's buried in the analysis menu, so you may not have seen it. What's new, I think it was either 8.2 or 8.1, DS9 8.2 or 8.1, is that it now automatically aligns on the world coordinate systems. So if you have an event list, it was really hard to get a mask to work with an event list because it was never quite the way DS9 has to bin the event list into an image. Getting the mask to align was actually really difficult. In 8.2 or by 8.2, you can now it now aligns it on WCS automatically, and you can play games where you can start adjusting the transparency. So you can now kind of see where things match up. And of course, why have just one mask whenever you can have more? So if I keep doing this and I load the moss exposure maps using different colors, so I can bring this up here, and just for fun, I can do something like I'm going to use the color medium blue. Okay, so now you can see the other, the next exposure map is there, and we'll open the last one, and I'll just call it green, just to make things easy. So now we have the three masks, and it looks kind of funky as far as the colors go. And this is because there's now the ability to blend the masks using basically blend the masks. So you can either pick, it's easier to describe by seeing. So by blending by source, so it basically goes by order. So the green one was the last one loaded, so that's the first one you see. The blue was the second, and the red was the last. You can go to darken, which basically subtracts the colors that overlap. So you get darker colors, or lighten, which is this. And screen is similar to lighten. Honestly, I don't remember the exact details of how they're different. That's one of those build questions we'd have to ask. But source lets you, like I said, control the order that you go in. You can't apply different the transparency is applied to all masks at the same level. Yes. So you can't apply different transparency to different masks, but you can control the transparency. And again, this works regardless of, there are actually fun things like, DS9 is now very adherent to the WCS standards. Unfortunately, there's some, especially earlier data sets that aren't. So it has to make some adjustments, and there are certain things like, very specific keywords need to be in the right headers for things to line up the way they're supposed to line up. So, if you end up seeing some weird things in where things aren't quite lining up, it's probably because the WCS isn't quite right in one of the files. Okay. So moving on to the next thing is, you're going to get a little preview here. So here I have new observation. And what I want to do is I actually want to detect some sources. I want to, there's a lot of point-like sources here. Now I could fire up chow in the terminal here and type, cell detect or whichever one I wanted to do. But one thing you'll be seeing later is that, again, in our analysis menu here, at the very bottom, and again, you will only see this if you start DS9 from within chow. If you launch DS9 outside of chow, either you've apt-get installed it, or you've downloaded the Aqua version and you're running it through the Finder or whatnot, you won't get this. You only get this menu if you've started DS9 within the chow environment. And from here, what I can now do is actually run some tools. And for right now, the only one I just want to run quickly here is I want to run cell detect, which is one of the chow source detect tools. Everybody knows wave detect. Wave detect is the gold standard for chow, although it's probably more, silver standard at this time. But it's a lot slower. So I'm going to use cell detect here. I'm going to do it really quickly and just use a fixed cell size. So it's going to run cell detect, and it's going to be done. And I can region select all, region width. So you can see these guys. Make sure you can see them. So you can now see all the regions are here. You can pan around and whatnot. The thing is, we know that cell detect gives us more than just positions, right? I mean, we have a position and we have shape information. So we have position and a radius, kind of thing. But we know cell detect gives us more. We know it should give us some kind of counts at the very least. So what this DAX application does, plugin does, is it actually saves all the files. So the cell detect output is here, and it'd be nice to be able to actually investigate this and look at it, look at the file. So one of the big new changes in 8.2, DS9 8.2, is there's now an application called Prism that's attached to DS9. And Prism in DS9 replaces Prism in chow. So there used to be a chow application called Prism, which was removed last year. So DS9 now has its own version of Prism, which is this file viewer. So from here, so by default, it will display the current file, information about the current file. I don't want that. I want to open this temporary file that cell detect created. And we get all the information from cell detect. So we get R's and DEX, we get X's and Y's. We get things like net counts. We get things like signal to noise. You can, if there are multiple blocks, you can page through the blocks. You can page through the header keywords. So if you use Prism and chow, this looks very similar because DS9 Prism is almost line by line, almost feature by feature the same. So one thing else you can do here is I can do things like plot. So I can plot net counts versus signals noise. And it's going to ask me this kind of stuff, and we'll let this go. And we get this wonderful little plot of net counts versus signal to noise. And it's not particularly attractive right now. You have these lines and whatnot. And you can actually, and again, plotting has been part of DS9 for a long time. There have been ways to plot generic data sets, not tied directly to the image you're looking at, but there are ways you can plot data before. And you can do things like, if I want to make this log, things like you have to do like graph, x-axis log, graph, y-axis log. There's a lot of clicking to change the appearance of the plot. So also now new is that there's now a single place to control all the plot parameters. And Antonella was spearheading this particular project. So now I can do things like change log. I can turn off the themes, and I can make it, and turn off the lines. So now my plots are there, and Sure, that's fine for right now. You can do things like, just the titles and all these kind of things. If you haven't played with the plot window, you can click and drag to zoom in, and then right click to zoom back out. And again, so this is a nice thing that, but so we have some outliers here. It'd be nice to kind of see what those are. It'd be nice to be able to interact with this a little bit. So, Prism is the basic viewer, so it can display any file. You can load an aspect solution file, you can load a bad pixel file, any fits data set. Actually, it can read, I think it can read VO tables and various RDB or CVS format files. You can actually run you can run DS9, you can run DS9 minus Prism, file name, and it will run Prism and ignore the whole DS9 window. DS9 window will be there and will be blank, but you can do this with any file. So that this is all great and whatnot, but this is tied to actual data here that we're displaying. It'd be nice to kind of display it not necessarily as just a generic table, but as a real catalog. So I can, let's close this out, and make sure I've got this copied. Back to our favorite analysis menu in the catalog tool, and now brings up this little guy, and I can import. And new recently, I think 8.2, is the ability to import fits files. And again, I can now import our cell detect file. And it's kind of hard to see because all the regions are here. So let me region, select all, and then region delete, selected regions, yes. So now we can see, instead of regions, we now have these little circle markers. So these are point markers that are at the location of RA and DEC, so the columns that are selected here. The coordinate system is specified here. I can do things like sort this table on decreasing signal to noise. If I click a row here, you'll see that the imager pans to that location and the source blinks for a second. Similarly, if I am in edit catalog mode, I can now click on the source here and it will get highlighted in the table. And actually, if I click and drag, I can select multiple rows. It's probably hard to see, but they're there. From here, I can also plot similar kind of thing. So I can do things like net counts versus signal to noise. And actually, I'm not going to do this, but you can do things like log signal to noise, or net counts +5, or you can do arbitrary expressions here. You don't just have to plot individual columns. So I'm just going to do what we did before, and we're going to tweak this a little bit to get log. Turn off that, and okay, so that's good. Now, similar thing, if I now select a row here in the table, not only does it flash here, but you'll notice that the color is now changed here in the plot. Similarly, if I click on the plot, the point changes here, the table updates. So it's this linked view. You've probably seen this in either using TopCat with maybe CSC view, or you may have seen it with GlueViz kind of thing. This idea of linking multiple views of the same data. Catalog-wise, there's a lot you can do here with the catalog. So for example, if you haven't played with the catalog, you can do things like, so I'm going to add a new thing that says, if the signal to noise ratio is greater than 10, I want them to be yellow, or let's do magenta. Apply. So now all the points that have a signal to noise ratio greater than 10 are shown in magenta, and the ones that are less than 10 are in green. And you can tweak this. You can do different text. You can do different size, radius. You can extend this for forever and ever. Okay, I am running a little behind, so let me get the last kind of parts of this part done ready. One of the other kind of changes, or one of the other new features of DS9 that's somewhat recent that people don't necessarily know about is the ability to do 3D images, to do cubes, to work with data cubes. This is a data cube of an HRC data set. We keep, everybody complains we only show ACES data. This is actually an HRC data set, but it's actually HRC in chip coordinates. So this is AR-LAC, one of the calibration targets, but it's actually in chip coordinates. So you actually see the dither pattern. And this is actually a data cube. You're seeing the front face of the data cube right now. I can set the coordinates to this, and you can see that the third axis here is actually time. I can now rotate this guy using the sliders here to control the orientation. I can also go into Edit, 3D, and click and drag to rotate this guy. Remember when I said about the multiple processors? The 3D rendering is using up all my processors here. So when you see my little CPU load, you can see it going crazy whenever you're doing this. You can also use regions with 3D with cubes. So if I go into edit region mode and draw a region, nothing happens. But now if I double click it, or you can go to region, get info instead. There's an analysis menu in here as well. Again, all the good stuff is in the analysis menu. I can now plot 3D. And what this is, it's a little hard to see there, but as I move this around, it's now plotting the third dimension. So this is actually a light curve. If you want to, because my third axis is time, this is a light curve of this guy. If your third axis was energy, this would be a spectrum. It all depends on what your third axis is. We can also then do things like animate this, create movie. So I can create an animated GIF. Everybody likes GIFs. We're going to do a 3D movie, and it's going to be and we're going to so it's now created a little animated GIF that you can now post on social media, and get thousands of views and have it go viral and all as well. Just to do kind of one more quick one here before we move on. So here's another 3D data cube. This is ABEL 1664, where now my third axis we can see is energy. So energy in EV. So, and again, we can now rotate this guy. This little cyan thing here, if we move this around, you can see the cyan plane move. And that's really useful for things like contours. So contour parameters. So 10, 10. So now as I move this guy around, you'll see that the contour applies to which plane we're looking at. And similarly, I can create a movie of this animated GIF slice movie. So it's going to go iterate through each of the slices. Come on. Oh, yes. So similar kind of thing. And you can mix and match the order of things. There's a lot more you can do with 3D. Yeah, you can actually do more than 3D. If you have a 4D cube, then this cube menu starts having more sliders for each of the additional higher dimensions. And you can change the axis orders and all of those kind of fun things. Okay, so that's DS9. So everything that, except for the cell detector bit, everything that I showed so far was DS9 native. Those are all DS9 functionalities. You get that Windows, Linux, Mac, whichever version that you happen to use. The things I'm going to talk about now are the DS9 edition, or the Chow editions that we've added to DS9 called DAX. If you don't know what DAX stands for, there's a wonderful article in the last Chandra newsletter, or the previous, the last fall Chandra newsletter, which is all about DAX, which was something I wrote. So of course it's wonderful. So we're going to look at one observation that's kind of our go-to observation. It's got all kinds of good stuff going on. This is an observation 635 of the Rho cloud. It's a 100 kilosecond observation, which we don't get anymore. But it has all kinds of nice goodies in here. All kinds of nice point sources, although not all these really are point sources. Some of these are actually blended point sources, but that's for a different topic. So we we said that this meshes together well with Sherpa, so I'm going to go ahead and get there. So one of the things that we talked about, or that we discussed internally, was making the easy things easy for users to do, which means not a lot of typing. I can tell you that we actually had a conversation with somebody that they didn't like some of the Chow parameter names because you actually had to hit the shift key because there was an underbar. So people don't like typing. They like they like interfaces like this where you can just drag and draw a region and kind of get the answer you're looking for. So I'm going to show you a couple things here quickly.
Kenny, sorry.
Yep.
So perhaps it might be a good time just to mention about regions, given the help desk tickets we get.
Sure.
Yeah, I wanted to say the same thing. Go ahead.
For any of you who have, I put this in the write-up, but if you've recently updated to DS9 and you find that you can't, if you're doing this and you're clicking DS9 and no regions are showing up, it's because there's a change a while ago that the default for the edit menu is none. The first thing that I do is I make sure that the edit menu is region. Then you can draw regions all you want to, and you're good to go. Then you can set that in your preferences. If you go to edit preferences, region or menus, edit. So that's where you can set that to be permanently the case. So one of the first DAX tasks that I use all the time, it's actually kind of hidden, but with a single region selected, if you hit the F1 key, the region will center itself. Now this is actually kind of a cheat because there is now a way in DS9 to do this directly, so centrally. But DAX had it first. So since it was there first, we've kept it around, even though DS9 now has that capability built in. So let's say we have this source here and we want to get the spectrum, we want to fit the spectrum. So normal chow thing to do would be run spec extract, run Tangent Reaver, run spec extract, start Sherpa, load the data, load the model, it's not hard, it's just there's a lot of typing involved to do that. So instead of that, in Chow, we have a Sherpa menu, and you can do a spectral fit. And it's going to ask me some of the kind of basic questions I need. So which model, all the models aren't listed here. The models get very specialized, so we've just kind of picked off the top ones that people might want to use. The absorption model, same thing. How do you want to group the data? Energy limits, low and high. Are there any additional commands you want to set? So if you want to set like the abundance, or if you want to change other advanced things, you can do that before the actual fit. The fit method and the fit statistic. So I'm just going to let this go. And you'll see as this guy is running, so it said nothing was actually selected. So the region wasn't selected whenever the task started. So it's just using the circle that's there. If you had multiple circles, it would use the one that was selected. You can see it ran spec extract for me. I didn't have to type all this stuff. It's made all these adjustments and whatnot. So next thing you then get is this, the DAX model editor comes up. So this is new as of last year, I believe, where you can now set the model parameters before you actually fit. So you can change the limits, the mins and maxes. You can freeze or thaw parameters. I'm just going to go ahead and fit this. And it's going to give me the fit results over here. And actually the values have been updated in the GUI. And now I can plot the results. While this is intended to look like a matplotlib plot, this is DS9 plotting. So this is the kind of thing that DS9 plotting can do. We can actually do a lot more, but this is one of the things it can do. So this is not not a horrible fit. It does look like there's something out here around 6.7 keV around the iron line. So let's actually just go ahead and add this back in. So add that in. So let's repeat this. Sherpa spectral fit. Leave everything alone except I want to add a Gauss 1D. You'll see one thing off the top is that because it's already extracted the spectrum, it hasn't done it again. It's used the same files as before. Now we get the Gaussian parameters here. Full width half max. This is in units of keV now, so 20 is pretty big. Position 6.7, that's actually pretty close. If I plot this before I fit, I can see that the Gaussian amplitude is way off. So, oops. 0.001. And I'll plot this. Okay, so that's not too bad. I can actually come up here and pull these values out from where they were before. So 1.4, and the amplitude was 0.001, 0.02. Plot, and we'll let it fit anyway. See what happens. Okay. Oops. As you know, getting plots or getting, you just can't fit tight plot and expect things to really work well. The world just doesn't work that way.
Yeah. Your gamma is too high.
Yeah, sorry. Okay. There we go. Okay, so you get the idea, you know, but that's the kind of thing that you would do at the command line, where you would, you know, up arrow, backspace, delete kind of thing. So same kind of thing, just through the GUI. You can then run confidence to get the confidence intervals. The other thing to notice here is that it saves all of the files and the actual commands are output in this directory that it tells you about. So you can actually restore the Sherpa session right where it was, or the actual Sherpa commands are stored in this thing. You know, this isn't necessarily the way you would write Sherpa commands, but if you want kind of a jumping off point, this kind of gives you a little bit of a framework to get started with. You also have the files here, so you can start with those. So we can fit spatial, we can fit spectral, we can also fit spatial. So I'm going to come over here and I'm going to make my data set a little bit smaller. So, so edit, I'm now in crop mode. So I can now come in here and cut this down. And this actually makes my data set smaller. We all know fitting images can take a long time. So the smaller you can make your data set and still have a reasonable estimate of things is all good. So here I've got a source. You know, it kind of has, let's zoom in here a little bit. You know, it has some inclination in this direction. You know, it doesn't look at all like a Gaussian, but that's what we're going to do with it. We're going to fit it with a Gaussian. So 2D fit. So the Gaussian, I'll leave a constant term in here to kind of act as the background. We'll let this go. We get similar looking GUIs before. What we don't get is the plot. You actually have to complete the fit to plot the model and the residuals. So I'm just going to let this run and now quit. So here I get the fit results. Now, unfortunately, I keep realizing this is a pain. I need to match frame on WCS to get the, so this is the model, and this is the residuals. And then you can see, I mean, it's not a, you know, the fit statistic is horrible and everything, but again, this is a quick way to get an estimate of things. So you get an estimate of the size, you get an estimate of the elasticity, those kind of things. In the 30 seconds I have left, so you can do more than just you can do more than just fitting. We saw source detect. You can do things like you can try extract this PI spectrum. You can extract a light curve. So 1,000-second time bins. We can extract the Gregory-Laredo light curve, GL vary, which looks very similar. We can, let me do this one quickly because I think this is kind of an important one. One of the other things that we can do is estimate counts and count rates. So if I call this guy background, I can now do source flux. I'm going to run marks as part of my TSF. Sorry, I'm running through this quickly here at the end here. So this is now actually, using this as the source and this is the background. It's running the source flux tool. It actually has run marks in the background to simulate the PSF. Okay, so it's all done. So these are my estimates of the flux. And again, the output that is produced by source flux can now be like read back into the DS9 Prism application. So you can get not only the counts and count rates, but you can get things like photon flux and whatnot. So one last thing is I'll put this in the for the DAX part. There's a series of a whole lot of there's 20 demos or 20 videos showing all the DAX tasks. You know, I didn't even touch on the image processing or many of the other parts of things. There's a YouTube, we have a YouTube channel and there are a whole bunch of demos showing how to use the DAX part of things. There's some introductory DS9 things, but not the advanced stuff, not the new stuff.